That's why let us review. What is electric current? Flow of electrons in a okay. Yes, exactly. So flow of electrons in a conductor. Flow of electrons in a conductor. Okay. So let us assume that the analogy for this flow of electrons is water flow from a overhead tank. This is a overhead tank. You are in the ground floor. You are in the ground floor. You are having a tap. You are having a tap. This is the tap at your wash basin. Am I correct or not? This is overhead tank. Why you are keeping the tank at first floor or second floor? Suppose you are happen to be at ground floor, means the tank is in the first floor or second floor. Why? To get potential energy is converted into kinetic energy. That's why you are getting flow rate. So a pressure is required. So indirectly, if we can talk in this way. So because of this height, there is a pressure difference between this point and this point. Let us assume that the pressure here is 0. Here, atmospheric pressure. The pressure here is atmospheric pressure. Here, the pressure is mgh. mgh. Mass, gravity, and height. So, mass and that's what I am saying. You are repeating. So, because of that, some pressure is developed here between these 2 points, between the point 1 and 2. There is a pressure difference. That's why there is a flow rate. You can notice that as the level in the tank decreases, you can notice that there will be a flow rate in the tap is reduced. Have you noticed that? Tank is going to become empty. That's why the flow rate is less. The pressure is reduced because the height of this building is say h, means this water tank height is about h, means initially total height is h plus h. As level decreases, this h decreases. That's why level also decreases. That's why pressure decreases. So flow rate decreases. So pressure difference between the 2 points, that is point 1 and 2, is important to get flow rate. Like that, in electric current, potential differences, this is analogous, identical. Pressure difference is required. Pressure difference is, potential difference is required for a flow rate of current. Okay, so in a electric current, how the circuit looks like? A battery will be there. What is this? A battery, a DC battery. Battery means DC only. A battery is there, say 5 volt. Here you are having one resistance of 5 ohm. Resistance is there. So here, this battery develops a pressure across this resistance. This resistance is like your tap. The resistance is because the tap, if you open completely, the flow rate is maximum. If you close partially, flow rate decreases. If you fully closed, it becomes insulator. No flow rate of water. If you completely closed, means no flow rate. You understand this? So this is like a resistance. So if resistance increases, flow rate decreases. So this is like this 5 ohm resistance. The tap is like this 5 ohm resistance. You have to imagine like that. Because you cannot see the flow of electrons. That's why we have to imagine like that. But you can see the water flow rate. So this 5 ohm, the pressure potential difference is 5 volt. That's why current through this is, I can say 1 ampere. How we got? By Ohm's law. What Ohm's law says? V is at constant temperature. You should not forget that word. The constant at constant temperature. At constant temperature. At constant temperature. Yes, yes. At constant temperature. The voltage, the potential difference across any 2 points is directly proportional to current through it. That is Ohm's law. Don't tell. If I ask you, tell. Otherwise, that also will be recorded here. So your okay, no problem. You can tell. If I didn't record, you can talk. I am recording. If I ask you, tell. Otherwise, don't tell. So 5 ohm resistance, 5 volt. That's why 1 ampere, because of Ohm's law. Ohm's law says V is directly proportional to I. Ohm's law says V is directly proportional to I at constant temperature. That is very important. Or V equal to Ri, where R is the constant of proportionality, or V by I equal to R. V by I equal to R. We can say in the other words, Ohm's law, the ratio of potential difference and the current through them is a constant at constant temperature. The constant temperature is very important. So V by I equal to R. So we can say the Ohm's law is V is directly proportional to I at constant temperature. So Ohm's law is very, very important to find the current through it. So how to, this is not analogy to this. To understand the pressure difference, I am telling this circuit. But this is not analogy. I can put the analogical circuit, mechanical circuit, that is water flow circuit for this. That is this way. Do you know that what is the function of pump? You are having pump, your home, no? You will pump the water from sump to overhead tank. So what is the function of it? It develops a pressure difference across 2 points. One is input, another one is output. It develops a pressure because a centrifugal fan is rotating. That's why low pressure is developed. That's why water is flowing from this side to that side. That is pumped to the overhead tank. So it develops a potential difference, pressure difference. So like that, I can put a circuit like this. So I can put, this is the pump. This is the pump. So I can put a fan. It is rotating. It is rotating. Suppose this is rotating this way, means negative pressure will be developed this side. That's why water in the bottom side will go upside. Am I correct or not? So here I am putting one hand valve. This is the hand valve. This is symbol for hand valve. That's why I'm using that. I'm connecting this way. Assume that the tube is filled with water. Assume that the tube is filled with water. If you turn on this pump, this is the pump. This is the pump. If you turn on the pump, it will rotate and it develops a negative pressure here. That's why the water in the bottom side will go to the point 2. Am I correct or not? That's why it will displace adjacent water. That's why there is a circulation of water from this side to this side. Am I correct or not? Till you stop this pump, there is a flow of water. This is identical to this circuit. This is identical to this circuit. Let us assume that initially this hand valve is completely open, no resistance at all. That's why the pump pumps at 5 liters per second or 5 liters per hour. Let us assume it pumps at the rate of 5 liters per hour. 5 liters per hour. I am closing this valve gradually. 50% I closed. What will happen? Now it is reduced to 2.5 liters per hour because the resistance is increased. The resistance to the flow of water is increased. That's why there is reduction in flow rate of water. You understand that? That way, this resistance resists the flow of current resist the flow of current, like this hand wall. If you completely close this hand wall, what will happen? Even though the pump is pumping, there is no flow of water because the valve is completely closed. Then it becomes insulator. Instead of resistor, if you put insulator here, there is no current flow rate. If it is in conductor, then there will be a flow of current. Resistor is conductor or not? Yes or no? Yes, resistor is a conductor, but it resists. It resist. I am saying that you must come. 11 o'clock means you may resist, but you have to obey. No other go. You may resist, but you have to obey. You should come in time. Like that, it resists the flow of current, but it has to obey. No other go. But because of resistance, there will be a flow rate may vary. Flow rate may vary. This conductor also having some resistance. This conductor also, this line is conductor. You said there is no drop we are assuming while solving the sum. But it also has some resistance. We are ignoring it. Suppose I am having 1 lakh rupees and 10 paise. What I will say? I have 1 lakh 10 paise or 1 lakh. 1 lakh only. Like that, the resistance in the conductor is negligible. That's why we are not talking about it. It is, we are ignoring that. I understand this point. Suppose I am having 55 paise. Suddenly I found another 10 paise. What I will say? 55 paise or 65 paise? 65 paise. Because then it becomes considerable amount. We'll compare with 55 paise, 10 paise is considerable amount. That's why I'll say 65 paise. Like that, if the resistance is negligible, this 5 ohm becomes very small, very, very small. Then the conductor resistance also comes into play. Do you understand this? So for 5 ohm, it is negligible. For 5 ohm, it is negligible. So every metal has some resistance. But we'll compare with usable part, it is negligible. We'll compare with the usable part, it is negligible. While calculating, we are ignore that and we are calculating. So every point has some resistance. Here also, not only this hand wall gives resistance, this path also giving resistance. You might have know that if you put so many turning points, the flow rate will decrease because resistance will be more. You understand that? So this path, this tube also having resistance, but negligible while compare with that hand wall. Like that, this conductor also has resistance, but it is negligible while compare with that resistance. By Ohm's law, we can find the current. What is the formula now? You can manipulate this V by I equal to R. That is V by R equal to I. V is 5 volt. That is potential difference is 5. Resistance is 5. That's why current equal to 1 ampere. Current equal to 1 ampere. So this is analogy for electrical circuit. Why I am saying this as analogy? Here, this overhead tank water is going to ground floor, but it is not again coming to the tank. But in electric current, the flow of electrons, you cannot tap these electrons here. You cannot tap. It should go again there because you cannot change the number of electrons in any metal. You cannot change. But you can force the electron to flow and again it has to come. You cannot take away. You cannot take away. That's why this is identical to electric circuit, not this. Not this. This second circuit is identical to electric circuit, not this, not this. This is identical to electrical circuit because you cannot take away the electrons. It should come again where it is started. It should come again where it is started. Because in a copper, how many electrons are there? 29 electrons are there. You cannot change that. If you change that, what will happen? It never be a copper. So you cannot change. But you can force for some time to flow. You can force it for some time to flow. But again, it has to come. If some electrons leaves from here, some electrons should come and occupy that place. That is possible. You cannot take away. You cannot remove. You cannot remove. That's why a closed path is required. That's why it is called closed circuit. If circuit is closed, it is against our conventional English. Gate is closed means what? You cannot enter. Am I correct or not? Circuit is closed means what? Electrons can enter. So it is not conventional English. Have you understand this? So circuit is closed means if closed, then only electrons will go to the starting point. Have you understand this point? That's why the second circuit is analogy for electric circuit, not the first one. Not the first one. Anyhow, the pump is identical to battery. The pump is identical to generator, not battery. I will understand later. Okay, anyhow, you can assume, at present you can assume it is like battery. At present you can assume it as a like battery. Okay.